Alright, let's start taking a look at the different types of chemical reactions in this unit. So we've talked about the structure of a chemical reaction, in other words, reactants going to products. If you have a catalyst, the catalyst would be written over the arrow. So what we want to do is start looking at individual types of reactions. The first thing we need to do though is go back to the 7 diatomics and make sure we understand what a diatomic is. So first of all, there are 7 of them, and if you looked on the periodic table, nitrogen, oxygen, fluorine, chlorine, bromine, iodine form what looks like a 7, and then you've got hydrogen over here. So instead of memorizing them, if you can look at the periodic table and remember that those 7 make what looks like a 7 and then hydrogen. So again, the idea behind a diatomic is that when it's by itself, in other words, if I wrote hydrogen reacts with oxygen, when we go to write hydrogen, we have to write H2. In other words, you would never have just one single hydrogen reacting with something. Hydrogen always has 2 hydrogens in a molecule. Same thing with oxygen. You would have the O2. In other words, we have one diatomic and another diatomic. However, when we go to write the compound that they form, in other words, we have H with a 1 plus charge, O with a 2 minus charge, when they crisscross, they form H2O. So in the compound, the subscript is dictated by the charge that gets crisscrossed. So we don't treat it like a diatomic in a compound. And you might say, well, hold on, there's a 2 there behind the H, so it is diatomic. Again, that 2 is there because of the 2 minus charge on oxygen. So when one of the 7 diatomics is by itself, it gets a subscript of 2. When it's with a compound, it gets the subscript dictated by the compound. So for example, if we had aluminum chloride, aluminum is 3 plus, chlorine is 1 minus. When we crisscross, it would be AlCl3. Alright, so let's start talking about different types of reactions. The first type of reaction we're going to talk about is called a combination reaction. And basically what it means is you're going to take one thing, you're going to react it with another thing, and those things are going to come together to form a compound. And remember, a compound is one element, another element bonded together. We also call this a synthesis because when you synthesize something, you're essentially making something, so you're bringing 2 things together to make one thing. All of the types of reactions that we talk about are going to have one underlying characteristic that you can tell what type of reaction it is. So a combination reaction, for us anyway, is always going to have 2 elements. So we have magnesium, we have oxygen, and remember oxygen's a diatomic, so we have 2 individual elements. We don't have any compounds. Now the diatomics technically are compounds because there's 2 of them, but we will treat them as if they're a single element. Okay, so what happens then is the magnesium and the oxygen come together to form a compound. So over here we need to make a formula of when magnesium and oxygen come together. So every time you write a formula, unless told otherwise, we're going to use charges. So magnesium is 2 plus, oxygen is 2 minus. When we crisscross and reduce, we get the formula magnesium oxide. The typical question is to ask, well, what happened to the 2? There's a 2 here for oxygen, and over here it's a 1. Remember, that 2 is there because oxygen's a diatomic. Over here, the subscript is determined by the crisscrossing. So if we crisscross 2 and 2 and reduce, we get 1 and 1. So in other words, that 2 and that 1 have nothing to do with one another. Let's take a look at the next one. We've got potassium, and it's reacting with chlorine. Now chlorine's a diatomic, so it's Cl2. When potassium and chlorine come together to make a compound, potassium is 1 plus, chlorine is 1 minus, so when they crisscross, it's KCl. So if we were going to balance these two reactions, we would have 2 chlorines, so we need to put a 2 there for 2 chlorines. Now we have 2 potassiums, so we would put a 2 there. And up top here, we have 2 oxygens, so we're going to put a 2 there, and then we'll balance the magnesiums. Now we've already talked about balancing equations, so that should be old knowledge at this point. All right, let's move on. All right, the next type of reaction we're going to talk about is called a decomposition. This is also known as an analysis, and basically it's the opposite of a combination. You're going to take a compound and you're going to break it up into its parts. So for us, it's always going to be 2 elements. Now there are plenty of compounds that are made with polyatomics, but for us it would always be 2 elements. So we have calcium sulfide. Notice the IDE ending, which would make it one single element. Sulfide is a 2 minus charge. Calcium is 2 plus. So when we crisscross, we get CaS. So what we're going to do then is break that up into the things that make it up. So we have calcium and sulfur. The only thing you want to make sure is that you look at the elements and make sure they're not diatomics. If they are diatomics, then you need to put a subscriptive 2. For example, aluminum oxide, we have aluminum, 3 plus, oxide, single element O, 2 minus, so when we crisscross we get Al2O3. So when it breaks up, we're going to have aluminum and oxygen. Now oxygen's diatomic, so put the 2 there. Aluminum is not, so we'll just leave it as is. And then you're going to balance. When you go to balance, you've got that 3-2 situation. So if we put a 3 here, 6 oxygens, and a 2 here, 6 oxygens, and then we'll balance our aluminums with a 4. So everything works out there. So we've got combination. Combination A plus B gives us AB, and the opposite, which is decomposition. Alright, let's look at one more type of reaction, and this type is going to be referred to as combustion. Combustion is an unusual type of reaction for us, and this is going to be a general description of combustion. Technically, and we'll talk about this later, but technically anything that reacts with oxygen we're eventually going to call a combustion. But these are specific combustion reactions. They're called hydrocarbons, so hydrocarbon, and they're always going to be made up of carbons and hydrogens. You could have some other stuff attached to it, but there's always going to be a carbon-hydrogen chain. So combustion is very simple. You're going to take your hydrocarbon, the other reactant is always going to be oxygen, and the 2 products are going to be carbon dioxide and water. So the other types of reactions we can figure out the products. For combustion, you're going to memorize oxygen is the other reactant, carbon dioxide and water. So every combustion reaction is going to have the same format: oxygen, carbon dioxide, and water. Now, like we talked about in class, there are combustion reactions that form carbon monoxide. Those are called incomplete combustion reactions, but we're not going to talk about those. We're going to assume all of our combustions are complete, so our only products are going to be carbon dioxide and water. And then you would just balance it based on what the hydrocarbon is. So we have 2 carbons, 2 carbons, 6 hydrogens, so we'll put a 3 there for 6 hydrogens. Now our oxygens, we've got 4 and 3, which is 7. And over here we have 2 oxygens, and this is bad because nothing times 2 equals 7, at least no whole number. So the one way that we can fix this, if you run into this situation, take your 2 coefficients, actually let me just erase them. So we had a 2 and a 3 there, and what we're going to do is double those. So we're going to have a 4 and a 6. So now we have 8 and 6, which is 14 oxygens, so we can put a 7 there. And then we just need to balance our carbons. We can do the next one, C4H4. 4 carbons, so we'll put a 4. 4 hydrogens, so we'll put a 2. Now we've got 8 and 2, which is 10 oxygens, and that's good because we can put a 5 there to make it 10 oxygens. Alright, so let's balance this third one. I did a little editing there if you saw it jump like that. So we're going to put a 3 here because we have 3 carbons, and then we have 6 hydrogens, so we'll put a 3 there. Now what we're going to notice here is that we have 6 and 3, which is 9 oxygens. So on this side we would need 7 here because we have 2 there. So this isn't going to work. So we're going to do that same thing where we make that a 6 and that a 6. Now we're going to put a 2 here to balance our carbons. We have 6 and 6. So now we have 4 oxygens here. And on this side we have 6 times 2 is 12 plus 6, we have 18. So since we have 4 here, we need another 14, so if we put a 7 there, that one balances. So that one's a little bit tricky, but again, if you just kind of work with it, and if you run into that issue with the oxygens, try doubling your coefficients here, and then rebalance everything. That might help. Okay, so I'm going to go through these next pretty quickly so we save a little bit of time. So magnesium bromide decomposes. So it's going to break up into magnesium and bromine. Bromine's diatomic, and you can see everything is balanced. Hydrogen reacts with oxygen. Both are diatomic. So we have 2 elements, so we're going to bring those together to form H2O, and then we'll balance it with our coefficients. We have sodium reacting with sulfur. Neither one of those are diatomic, so we'll leave them like that. It's a combination, 2 single elements. So when we bring sodium and sulfur together, we'll have the formula Na2S. The reason for that, sodium is 1 plus, sulfur is 2 minus, so when we crisscross, there you are. And we'll put a 2 there. Aluminum reacting with oxygen, again a combination, 2 elements. Aluminum oxide, again aluminum is 3 plus, 2 minus, so when we crisscross, to balance that we'll put a 3, a 2, and a 4. So let's move on to the next one. Dicarbon hexahydride undergoes combustion. So again, our other reactant is oxygen, carbon dioxide, and water are our 2 products. So let's balance. 2 carbons, 2 carbons, 6 hydrogens, 6 hydrogens. So we have 4 and 3, which is 7 oxygens. Not good. So let's make that a 4. Let's make that a 6. Let's rebalance our carbons and hydrogens. So now we have 8 and 6 is 14 oxygens, so we'll put a 7 there. Iodine reacts with potassium. Iodine's diatomic. Potassium is 1 plus and iodine is 1 minus, so their formula would be Ki. We will balance by putting a 2, and a 2. Tricarbon octahydride undergoes combustion. So you should be getting pretty, that's no good. How about that? You should be getting pretty good with combustions. We're going to balance our carbons. We'll balance our hydrogens. 6 and 4 is 10. Thank goodness we finally have an even number of oxygens. And we'll put a 5 there for 10. Okay, I ripped through these last seven equations fairly quickly. So you might want to go back and rewind and look at this again. And again, if you have questions about it, you can either email at Hannon in Chemistry, or you can simply ask in class. The next vodcast, then, we will take a look at the other types of reactions. Until then, see ya.